Fire is not always visible. It can burn underground, underwater, inside the air itself. The surface may look unchanged, but beneath it, something is still burning. Nature looks calm, beautiful, silent, alive. But beneath that surface, there is force, pressure building, gas rising, ice cracking, wind sharpening. A lake can suffocate a valley. A tree can burn your skin. A storm can erase direction. This is Nature is Scary, the planet that does not care. We recognize fire when we see flame. Orange light, smoke, ash, heat moving upward. But nature does not need the symbol of fire to make fire real. Combustion can hide under soil. Heat can move through rock. Gas can rise from vents. Lightning can ignite a landscape without rain. And seawater can boil against volcanic heat in complete darkness. The surface may look stable. A street, a hillside, a forest floor, a black ocean trench. But below it, energy is being released. Slowly, continuously, sometimes for decades. This is not the fire of campgrounds and torches. It is geological fire, chemical fire, atmospheric fire. And because it is hidden, it is harder to understand, harder to control, and easier to underestimate. The first version of that danger can burn beneath a town long after the town itself has gone quiet. Hidden beneath the feet of residents in certain parts of the world is a force that never sleeps, an underground coal fire. An underground coal fire does not need open flame at the surface. It only needs fuel, oxygen, a path through broken rock, and time. Coal seams can ignite from mining activity, spontaneous heating, wildfires, lightning, or exposed burning material. Once fire enters the seam, it can move through the ground like a slow animal, hidden by soil, fed by cracks, protected from weather. Centralia, Pennsylvania, became one of the best-known examples. A fire beneath the town began in the 1960s. It continued below streets, homes, and roads. The danger was not one dramatic wall of flame. It was heat underfoot, toxic gases, unstable ground, smoke appearing from places smoke should not be. Underground coal fires have been documented in many parts of the world. Some burn for years, some for decades, some become part of the landscape itself. The terrifying part is not only that the ground can burn, it is that from above, it may still look like ground. A buried fire does not stay buried in one way. It changes the ground around it. Heat dries soil. Rock fractures. Voids expand. Gas searches for exits. What begins as hidden combustion can become a surface hazard. A crack opens. A road buckles. A vent releases heat. A patch of vegetation dies while the landscape around it survives. The air above the ground can become part of the warning. Carbon monoxide, carbon dioxide, sulfur compounds, particulate smoke, pollution rising from a fire no one can see. The problem is not only heat, it is uncertainty. You may not know where the hollow has formed. You may not know where the gas is moving. You may not know which part of the surface is still supported. That is why hidden fire feels different from open fire. Open fire tells you where it is. Buried fire makes the ground lie. And below the ocean, heat becomes even harder to recognize. Underwater fire is not flame in the normal sense. It is heat from the planet escaping into water. At hydrothermal vents, seawater sinks through cracks in the ocean crust. It meets hot rock and magma-heated systems below. Then it rises back out, loaded with minerals, chemicals, and extreme heat. Black smokers can release dark jets of mineral-rich fluid into near-freezing deep ocean water. The fluid can be hot enough to sound impossible, yet it exists because pressure keeps the system from behaving like water at the surface. There is no campfire, no sparks, no orange flame, only black water pouring from the earth, building chimneys from minerals, and feeding ecosystems that do not need sunlight. This is fire translated into geology. Heat without air. Combustion replaced by pressure, chemistry, and volcanic energy. But when the earth vents heat, it often vents something else with it. Gas. Volcanic heat rarely travels alone. It carries chemistry. Beneath volcanoes, magma releases gases as pressure changes. Water vapor, carbon dioxide, sulfur dioxide, hydrogen sulfide, hydrogen fluoride, carbon monoxide. Some rise through vents. Some collect in low areas. Some mix with moisture and sunlight, turning into volcanic smog. To the eye, a volcanic zone may look like steam, rock, and open air. But the air can be chemically altered. Sulfur dioxide irritates lungs and eyes. Carbon dioxide can settle in depressions. Hydrogen sulfide can be dangerous, even when the landscape looks calm. That is why volcanic fire is not only heat, it is atmosphere, it is chemistry, it is invisible exposure. The ground burns below, the air changes above, and between them, the body becomes the warning system. The most frightening fire may be the one that enters unnoticed. Not through skin, not through impact, through breath. Volcanic smog can form when volcanic gases react in the atmosphere. Tiny particles and acidic droplets can travel with wind. What began as heat underground becomes irritation in the lungs, stinging in the eyes, and damage carried far from the vent. Carbon dioxide creates a different trap. Because it is denser than air, it can collect in low places under certain conditions. A hollow, a cave, a valley, a depression near volcanic ground. It does not need a smell. It does not need smoke. It only has to replace enough oxygen. This is where fire becomes misleading. The danger is no longer the burn. It is the altered environment around the burn. A landscape can be hot below, toxic above, and peaceful at eye level. And sometimes the heat does not wait for a volcano. It falls from the sky in a single strike. Lightning is fire delivered instantly. It strikes before the landscape can react, before smoke exists, before flame spreads. In dry storms, rain may evaporate before reaching the ground, but the lightning still arrives. A tree becomes an ignition point. Dry grass becomes fuel. Wind becomes the first accomplice. From a distance, the storm may look harmless. A dark cloud, a few flashes, no heavy rain. But on the ground, the conditions have already aligned. Dry fuel, electrical discharge, moving air, low moisture. Fire begins as an event smaller than the landscape. Then the landscape teaches it where to go. Some fires are born from the sky, then shaped by the ground. Others become powerful enough to shape the sky back. Large fires do not only consume air, they move it Intense heat forces air upward. Cooler air rushes inward. Turbulence forms. Rotation tightens. Under the right conditions, fire can create a spinning column of hot air, flame, ash, and debris. People call it a fire whirl. Sometimes, when the rotation becomes stronger and more organized, it is described as a fire tornado. The name sounds unreal, but the physics is not magic. It is heat, wind, instability, and rotation collapsing into a dangerous shape. This is fire changing the rules of air. The burn is no longer only on the ground. The atmosphere becomes part of the event. And when the air begins moving like that, a fire is no longer just spreading. It is building weather around itself. Fire is easy to fear when it is visible. A flame tells you where not to stand. Smoke tells you where not to breathe. Heat tells you when to move, an invisible warning. But nature hides fire inside systems. In coal seams below towns, in magma-heated water under oceans, in gases rising from volcanic ground, in lightning that strikes dry earth, in air pulled upward by its own heat, the danger changes form. Nature's heat remains hidden. Combustion becomes ground failure, a quiet collapse. Heat becomes chemistry, natural systems in flux. Gas becomes exposure, a lethal atmosphere. Weather becomes ignition, static in the air. Wind becomes rotation, a spiral of energy. That is what makes this kind of fire so unsettling. It does not always burn where you expect. It does not always glow. It does not always announce itself. Sometimes the surface remains quiet. The road remains empty. Silence in the wasteland. The water remains black, still and cold. The air remains clear, a deceptive peace. And beneath it, or inside it, or above it, energy waits. Energy is still being released. Because fire is not only flame, it is a process. And the planet has many ways to keep it alive. Heat can overwhelm the body without visible flame. Water can boil from the earth. Deserts can trap temperature. The body can begin shutting down from inside, and survival becomes a race against biology. What we have seen is not nature turning evil, it is nature operating normally. Gas rises, water moves, storms form, and when the conditions align, life gets caught in the system. Because the planet does not choose victims, it only follows physics.